Next is SkyeLabs with the North Carolina School of Science and Mathematics.
Picture yourself exploring the frigid Arctic, or stay in the midst of a freezing winter as you travel to work. How about just skiing down your favorite slope? In any case, you probably pictured wearing one of those puffy winter jackets. What if there was a jacket that was as thin as a windbreaker, but could keep you warm in even the most severe cold? An advanced aerogel that could accomplish such a feat could also have many other commercial applications. This is where we come in with EcoGel, a sustainable apparel insulator. Hi, my name is Prachiti Shakarkane, the CEO of SkyeLabs.
Hi, my name is Callista Holishak, the Chief Technology Officer of SkyeLabs.
Hi, my name is Suhani Ramchandra, the Chief Financial Officer at SkyeLabs.
Hello, I'm Rashika Ray Chaudhary, the Chief Operations Officer of SkyeLabs.
Drawing inspiration from NASA's game-changing aerogel technology, we are working on a carbon biopolymer aerogel derived from cellulosic fiber. EcoGel is naturally sourced. Its earthly derivation, coupled with a highly flexible, non-toxic, and water-resistant nature, make it an ideal candidate for applications in high-performance apparel. EcoGel also proves competitive in comparison to current apparel insulation. Current forms of apparel insulation include down and synthetic filler. Down filler loses its insulatory properties in wet conditions and when compressed. Down is derived from the feathers of geese and duck, which are plucked from the chests and lower backs of these animals while they are still alive. In comparison, synthetic filler, although more cost-effective and water-resistant, dries out easily and has lower compressibility, adding bulk. Patagonia and the North Face currently partner with Primaloft, a synthetic down manufacturing company, to use their insulatory material. Patagonia, the North Face, and Columbia have all attempted to use aerogels in the past for their jackets, although none have had significant success. In one attempt, it was found that the silica aerogel tended to flake out of the fiber blanket with movement, and also tended to suck out moisture upon contact, leading to the skin drying out. This meant that the material had to be encapsulated, which cut the breathability down to virtually zero.
As compared to Primaloft, EcoGel is able to provide significantly more insulatory capabilities with just 25 millimeters of thickness, while simultaneously maintaining breathability. Since EcoGel's production process is less energy intensive as compared to silica aerogels, the product will also enable viable production costs and market price. These high-performance apparel brands have displayed a significant emphasis on environmentally sourced products, with Patagonia's tagline being, "We're in business to save our home planet." Patagonia even pushed for Primaloft to adopt more environmentally conscious production methods before they would allow a partnership. With these values and a need for powerful insulation technology, we've identified high-performance clothing manufacturers as ideal customers for the sustainable EcoGel's market entry. We'll be looking to establish partnerships with these companies to incorporate EcoGel into their products. The high-performance company Oros has developed an aerogel insulator solar core, which, although effective, has limited economical landscape and is largely proprietary. We are looking to partner with this company to potentially fuse the best of our aerogel technologies and perform temperature testing. With environmental concerns at the forefront of our country, consumers are becoming increasingly environmentally conscious, seeking sustainably sourced apparel over cheaper, yet harmful alternatives. The high-performance apparel market, which is intended for athletic wear and protective gear, faces an increasing demand for transparency as to what materials it uses, which is what EcoGel will work to address. The high-performance apparel market was valued at $8.2 billion in 2020 and is expected to grow at a considerable rate of 9.6% between now and 2026, presenting a significant market opportunity for SkyeLabs' EcoGel. But EcoGel's insulatory capabilities span across several industries: aerospace, construction, and transportation. Rocket fuel tanks are kept at extremely low temperatures, and while materials like polyurethane foam are lightweight, they are coupled with ecological and health issues, as well as a lower insulatory power when compared to the aerogel. Respiratory sickness and skin and eye irritation from the physical exposure during the installation process, and the energy-intensive processes are outcomes of polyurethane. The presence of isocyanates carry highly reactive chemicals, increasing the toxicity of polyurethane. EcoGel's cellulosic structure enables a non-toxic and porous material, making it the ideal candidate for use in the rocket fuel tank.
But not only is EcoGel a powerful and flexible insulator, it also displays EMI shielding capabilities and flame retardancy, which is why the material is so applicable to the aerospace industry. While current aerospace companies purchase separate materials for insulation, EMI shielding, and flame retardancy, EcoGel supplies a solution with all these properties into one product, all at a competitive functionality. Unlike polyurethane foam, which has an unforgiving production process and requires on-site manufacturing, EcoGel can serve as an accessible insulation at an affordable price. Because of this, upon going to market, EcoGel will target startup aircraft manufacturers to partner with, as we see them in comparatively immediate need of an accessible, low-cost, and versatile aerogel solution like EcoGel. We've identified startups like Launcher, Ampere, Vico, Zunum Aero, MagniX, and Joby Aviation for this purpose. We see NASA benefiting from our unique product as it has a wide range of applications to meet their needs. EcoGel can be used on NASA's rovers, spacecrafts, space stations, and other facilities as a thermal insulator, EMI shield, and flame retardant, all while supporting the environment. Commonly employed silica aerogels are known to be extremely brittle, which is a significant point that EcoGel solves by incorporation of cellulosic fiber of greater tensile strength. In the future, EcoGel's thermal properties can potentially be used for planetary exploration. Recently, NASA's Perseverance successfully converted atmospheric carbon dioxide into breathable oxygen gas. The system used for this, MOXIE, contains a solid oxide electrolyzer, which operates at a high 800 degrees Celsius, requiring a strong thermal insulation system. While aerogels are already being used for this, they could be improved with EcoGel, which reduces overall costs compared to traditional silica aerogels that are currently used. Many of the aerogels currently on the market are in the form of silica and TMOS reagents, which even in small concentrations can cause lung lesions and even blindness if in contact with the eye in larger concentrations. As a result, the fabrication and testing of silica-based aerogels is limited for the need for caution in handling the toxic TMOS reagents.
Some other commonly used forms of insulation upon commercial aircraft include fire protective insulation blankets or ceramic fiber fire blankets, as well as mica sheets. However, the mining of mica poses environmental risks and health concerns for miners, with repeated exposure to mica powder characteristic of causing lung scarring and irritation. The mining process is labor-intensive and often carried out by hand in developing countries such as India, where the workers are sparingly paid. Mica mining is also conducted illegally in some countries, heightening the risks for those involved and to the environment because of low regulation. As compared to this, EcoGel not only provides a safer alternative, but also displays significantly more insulatory properties coupled with EMI shielding and flame retardancy. We are a very early stage startup, conducting prototyping of aerogel at the North Carolina School of Science and Mathematics. Although we haven't been able to characterize our product's physical attributes yet, academic literature supports the idea of superior flexibility, flame retardants, and EMI shielding. We are here seeking strategic partners that can assist in this physical assessment. Having been able to complete the initial parts of EcoGel's production, more intensive labs and heating equipment will be required to complete the prototype. We will be reaching out to local universities such as Duke and NC State to scale prototyping in the coming months. We are requesting consultation and mentorship from a subject matter expert within chemical and material engineering to validate and expedite our production efforts. We're also looking to have discussions with NASA subject matter experts familiar with production of aerogels, as well as potential access to NASA testing facilities to test material properties from our initial production run. While we are in the process of filing a provisional composition of matter patent, we are also looking for someone to help us develop an IP strategy. In the coming months, we are also looking to apply for SBIR and STTR programs funding to raise seed money.
Once brought to market, EcoGel would be one of the first commercially available biopolymer aerogels. Pioneering the future of environmentalism and technology, we at SkyeLabs are dedicated to advancing our materials both on Earth and beyond. We hope that you'll help us in pursuing this mission. Thank you.
All right, thank you. Do we have any questions?
Hey, Robin, this is John. I have one.
All right, great. Go ahead.
So sustainability is a significant strength for this technology, especially for your application. But NASA is also very interested in aerogels, especially for higher temperature applications. But as a carbon-based solution, it may be limited to only vacuum environments. And so I'm curious, have you guys assessed the upper temperature limits of your aerogel?
Thank you for that question. So we actually haven't been able to perform testing on our product yet, just because we've had access to limited facilities, but we are planning on conducting that testing in the coming months at local universities. So that is something that will be looking.
Great, thank you.
Can you guys hear me?
Yes.
Yes.
We can now, but you were muted, Robin.
All right, we're having some technical difficulties. Hold on. Alec, can you take it?
Ramona has a question.
Yes. Let me ask, I read about the banana fiber as your source, but I presume this can use any type of cellulose. And, or that's one question. And then another is, have you done some comparisons on the volume and weight of the raw materials that you would bring versus the final product? Should we use this for an in-space application, such as in a hab or whatever the case? We're trying to minimize volume and weight of items that we bring. And so I'm trying to understand what it would take to use it in those space applications.
Yeah, thank you for that question. So in terms of if another cellulosic fiber can be used, I'm sure it can, but we decided to use the one that we've selected in particular because it does display certain properties that are useful for creating this aerogel. I can't talk too much about it right now, but I'll be certain to talk with you about it later on. And in terms of like different weight compositions of like the fiber versus like I guess like the composition of our product in general, we've assessed like different like by weight ratios for creating this product. We haven't actually been able to, I guess, physically test on them, but we have understood that, for example, increasing the cellulosic concentration will increase the, I guess, tensile strength of our product versus decreasing that will result in a reduction of that tensile strength.
Okay, I'll be glad to chat with you about that at the table regarding obtaining cellulose in space. Thank you.
All right, Rich, it looks like you have a question.
Yes, thanks, Robin. Great presentation, ladies. Did I hear you correct in the presentation that you were thinking of working with Oros Apparel, or do you see them as just a competitor?
Working with them, that's right.
Okay, so I guess the question then, because my fund just invested in Oros, which is interesting, that's why I asked the question. Will your aerogel or gel, will it be in monolithic slabs, or will you try and weave it into the fabric that you're working with?
Thank you for that question, and Callista can take that one.
So thank you for that. So what we were thinking of is for the aerospace applications, we were going to have it in more of a slab thing, but for the apparel applications, we're just going to supply our gel directly to the companies such as Oros, so that they can incorporate it into their products how they would feel fit. And with that, we don't have a product right now, so we're going to need to do more like thinking on that to decide how we would incorporate it specifically with that company. But we're going to look, I guess, just partnering, and we're going to work on like customization, so we can customize our product specifically for those applications with the companies.
Okay. So one last follow-up question. You said that I don't know if I heard you right. You said that there was some kind of shielding aspect to the gel. Could you explain a little bit more about that, please?
Yes, thank you. So, what we actually have is we have EMI shielding capabilities because of the use of specific ingredients, and I can definitely talk more about that with you later. So, with this EMI shielding, it might not be so useful for the aero because it's an on-Earth kind of market we have going, but it's going to be very useful for the aerospace, and we can actually increase and decrease those EMI shielding properties based on the market and based on our customers' needs.
Okay, thank you.
Thanks, Rich. Paul, you have a question?
Yeah, Paul Masson, this is a very nice presentation. Two-part question. First is, you said that you're looking for a subject matter expert. We can deal with this more in the impact, but in general, what is the kind of expertise you're looking for next for your next stage of development?
Thank you, and I'll pass that question on to Rashika.
Absolutely. So, one of the biggest things that we're looking for in our product development is particularly being able to integrate our EcoGel properties into these apparel, such as we talked about before, either weaving it in or using it as slabs. And we'd like to work with someone experienced in biochemistry and being able to help us with that. Of course, we also mentioned being able to help us with our IP process, which is a huge part in our future work.
Okay. And the other quick follow-up question is, what was the original experience that your team had that led you down this path to try this?
Absolutely. So personally, I am experienced in science research, having done multiple years of biochemistry work and published papers on nanoparticles, and I believe that some of our other members, such as Suhani, has been experienced in business and marketing, having taken multiple courses and seeking experience, as well as other previous research experiences from Kalista and our CEO, Prashidi. And together we just came together as a group of friends, and we're seeking different innovations that we'd like to pursue as research.
Thank you very much. Appreciate it.
Thank you.
Thanks, Paul. Chandra?
Hi, great presentation. So am I hearing you correctly that you're looking for mentorship in several areas of business?
Yes, that's correct.
And do you have a exit strategy yet? And it's okay if you don't. It sounds like those are pretty early, but like a company white labeling your product or acquisition, are you looking to build a company?
So we don't have an exit strategy in answer to your question, but if we were to like expand where another company were to acquire our product and our IP, then that's something we'd be, I guess, interested in looking at what the next steps would be for that.
All right. Thank you, Chandra. Next, Alex.
Thank you. Great presentation. Could you talk a little bit more about your IP process and where you are in that?
Yeah, so right now we're in the process of filing our provisional patent based on composition of matter. And then after that, the next step for us would be a non-provisional patent. And as of now, we're not planning on leveraging any other IP. But we are definitely looking for somebody to help us plan out our IP strategy for the future.
Great, thank you.
Max, go ahead.
I have a basic question. How much of this stuff have you guys produced? In your video, you showed some vials. How much do you have on hand?
So Suhani can answer that question.
Thank you for that question. So currently we're still developing our first prototype and we're creating a cryogel solution. And we've been able to create a soil gel solution. So the next step that we have is a freeze drying process. We just haven't been able to get to that step yet because of the pandemic and we haven't entered the lab in a while. But in roughly 2 to 3 weeks, one of our members will be able to go back. So hopefully she'll be able to finish that for us.
All right. Well, thank you very much, SkyeLabs.